Okay, here we go. This is objective 3G, part 1. We're going to have a 3G part 2 later on. Okay, I can model and graph a direct and an inverse variation equation. Okay, so what is a direct variation? Well, in a direct variation, an increase in one variable means a proportional increase in the other variable. Okay, so make sure you get that down. And then the equation looks like this. You would have a y and an x, and then you would have a k. So it's y equals k times x. And the k is a constant number. So it's a number that doesn't change. Constant number. As opposed to the x and y, which are numbers that are changing. If you put in a certain x, if you put in a certain x, a certain y will come out. Okay, let's go ahead and make a table and a graph. So we're going to actually have to come up with an equation where k is a number. So I'm going to give you the equation y equals 2x. And then we're going to create this table. So we have x and y, and then we're going to pick some points to use. And I'm just going to choose some x's, and I'm going to choose -2, -1, 0, 1, 2. Okay, these are usually typically some good x's to try on a lot of graphs, not all of them, but at least on a lot of graphs, especially when you're multiplying, because we don't need to find certain numbers that are going to be divisible by a certain number. You can just go ahead and multiply any number, and it's going to be easy to figure out. Okay, so if I plug in -2, I get -4. If I plug in -1, I get -2. If I plug in 0, I get 0. If I plug in 1, I get 2. And if I plug in 2, I get 4. So let's plot these points here. So -2, 1, 2, 3, 4. -1, -2, 0, 1, 2, and 2, 4. Connect the points, we get a line. So a direct variation looks like a line. Okay, now let's go and see what an inverse variation looks like. So in an inverse variation, the two variables constant product. And what does product mean? Product means to multiply. So that means that our two variables, so x and y, would multiply together and have a constant product. So k. So once again, k is the constant. Another way to write this, since we're used to seeing a lot of equations with y by itself, we can go ahead, since these are being multiplied together, we can divide by x, and then we would have y equals k divided by x. All right, so let's see what this would look like. Oh, I forgot to do something up here. I want to show you how an increase in one variable means a proportional increase in the other variable. So what that means is these are going to go up by the same amount each time. So over here, each x, I'm just adding 1 to get to the next one. Add 1, add 1, and so on and so forth. What that means is on the right-hand side, for the y's, it also has to go up by the same amount each time. It doesn't have to be the same as what's over here. Oftentimes it won't be, but it does have to increase by the same amount each time. So -4 to -2 is adding 2. -2 to 0 is adding 2. 0 to 2 is adding 2, and so on. So it's a proportional increase. Okay, so now we can come back to this, and we'll make a table and see what pattern we see in that table. So we're going to choose some x's, plug them in, and find out what the y is. Now I'm going to choose some specific x's here. I want to give you an equation. That will help. I cannot make a table for this equation because there aren't any numbers in here, or there isn't a constant in there. So I'm going to go with xy equals 2. Okay, and then I'm going to rewrite it. I'm going to divide by x. So I get y equals 2 over x. And this just makes it a little bit easier to find the y because I'll plug in the x and find out what the y is. Okay, I'm going to choose some numbers here that are going to show me the great shape of the graph. I know what this graph looks like, and I want to make sure that we're kind of seeing what's going on here. So I'm going to pick some specific numbers. So I'm going to go with -2, -1, -0.5, 0, +0.5, +1, and +2. Now, it doesn't mean that every time you have an inverse variation, these are the numbers you have to use, but I just wanted to use this because I want to actually see what's happening with the graph, and I kind of know what these will give me. All right, so 2 divided by a -2 is a -1. 2 divided by a -1 is a -2. Then 2 divided by a -0.5 is going to give us -4. And then 2 divided by 0. Well, 2 divided by 0, which you may or may not know, you can never divide by a 0. You can have a 0 divided by any number. That would be 0. But you can never have a number and divide it by 0. Anytime you divide by 0, it's undefined. Okay, so right here, when I have 0 here, it's undefined. And we'll see what that looks like in the graph in just a moment, but that's going to be undefined. If you were to type this into your calculator, 2 divided by 0, it's going to say error. It won't say undefined, so you have to know that the reason it's saying undefined is because you're trying to divide by 0. All right, 2 divided by 0.5 is 4, 2 divided by 1 is 2, and 2 divided by 2 is 1. So let's go ahead and plot these points here. -2, -1. So -2, -1 is right there. -1, -2. And then 0.5 is kind of right here in the middle, and then it's going to bring me down to -4. All right, undefined. What that means is there's going to be no y's on here. Where x is 0, which is right here, there's not going to be a corresponding point on the y-axis. So I'm going to skip over it. And then I'm going to go to 0.5, which sends me up to 4. I'm going to go to 1, which sends me up to 2. And I'm going to go to 2, which sends me to 1. All right, right now, you might be tempted to draw some sort of zigzagging thing that goes across the y-axis. But remember, because it's undefined, that means that nothing can go here. Okay, you can't cross over. What we call this is an asymptote. When we have something that the line gets closer and closer to but doesn't cross over. And I'll show you how it's going to get closer and closer to it. And you don't have to draw this in whenever you graph this, but just so you know that we're not going to cross over it. Let's take a look at some other points on here. I kind of see the shape of the graph, but I feel like maybe I'm not getting enough points. So let me try something else. What's happening here? It looks like it's kind of curving, but then is it going to go up past here? What's going to go on? What's going to happen? So I'm just going to pick another number on here, like let's go with -4. If I put in -4, well, 2 divided by -4 is -1/2. So if I go over here to -4, -1/2. So sometimes you need to keep going until you have enough points to see what's going on. Well, I'm starting to see a curve here. Well, what if I were to plug in -10? What does that give me? So 2 divided by -10 is -1/5. So I'm kind of starting to see a pattern here. As the bottom gets bigger, as this x gets bigger, the y's get smaller, right? So if I have 2 over 10, that's 1/5. If I have 2 over, let's say, 100, that's 1/50th. If I have 2 over 1,000, that's 1 over 500. So as the denominator gets bigger, the number is actually getting smaller. Right? It's getting smaller and it's getting closer to 0. So as I go this way on my x's, I'm getting closer and closer to 0. And so actually what this graph looks like is it does this kind of swoop, comes up, and then it never crosses the axis. It just keeps getting closer and closer and closer, to the x-axis without ever crossing over. The same thing happens here. Okay, we're never going to cross over this line here where it's undefined. We're just going to get closer and closer to it. Okay, same over here. I could plot some more points in here, like +10. If I were to put a +10 in here, well, 2 divided by 10 is 1/5. So over here at 10, I'd be at 1/5. So it's going to do the same thing. It's going to come really close to these axes, without ever crossing them. Okay, so every time you have an x in the denominator, this is what you're going to end up with. Okay, this is an inverse variation, and it looks like this. It looks like these little curves that are going the opposite direction like that. Okay, so now we need to graph these two equations. And we're just going to make a couple of tables for them. I'm going to change this one so it's y equals -4 divided by x. And I'm going to make two tables, and then I'm going to graph them. All right, so where we're going with this is tables are always nice to use, but you kind of need to know what these graphs look like generally sometimes to know if you're doing this correctly. So I already know that this one right here, it looks like, let's flip back here, it looks like this equation, right? I have an y and an x with a constant number right there, and the other one looks like this equation, one of these. Looks like this now that I've changed it. So I know that this one's going to look like a line, and this one's going to look like that swoopy thing where it's not touching the axes. Right? And I don't know, they might not be facing that exact way, but generally speaking, I know that anytime I have a direct variation, it's going to be a line facing some way, and anytime I have an inverse variation, it's going to be these swoopy things facing some way. So now let's just plug in some numbers. So let's go ahead and use -2, -1, 0, -2, -1, 0, 1, 2, see what we get. And I'm actually going to use the same numbers over here, -2, -1, 0, 1, 2, because I'm looking to see where these are going to intersect. Okay, and if they're going to intersect, they have to have some matching points in my table, and then I'll know that I have enough points to actually figure it out over here. All right, so -2 times -4 is 8. Then this is 4. This is 0. Remember, I can multiply by 0. That's not a problem. That has not changed. And then coming over here, -4 divided by -2 is a +2. Then we have 4. Then we have, what is this? Remember, this is called undefined. You can just abbreviate like that. -4 and -2. All right, now I encourage you to pause the video and see if you can plot these on your own. This should be a piece of cake. This might be a little bit harder. Okay, know that you're going to get this kind of swoop. I'll give you a hint that it's not necessarily in this position. But plot these points. Remember that you can't cross the X or Y, and then rejoin me when you're ready. Okay, hopefully you gave this a try yourself. So my line looks something like this. And now I have to do my inverse. So let's see what I have so far. I have -2, 2. I have -1, 4. Well, there we go. Here's where we're intersecting. So we've already figured out where we're intersecting. Let me highlight that in my table. Well, from my table, I can also see that I have some matching points here. And in my graph, I can see that that's where they're going to intersect. I also have a couple of matching points here. So at 1, -4, I should also see an intersection when I get done graphing. But I want to be able to do all the parts. Okay, it says to graph, and it also says where do they intersect. Okay, so I'm here. 0 is undefined, so I don't have anything here. Then I skip over the y-axis to 1, -4, and I have a point, and 2, -2. Okay, so right now, I just have these 2 points that I can connect. Okay, I'm pretty familiar with this graph, so I know what it's going to look like. But if this isn't enough information for you, then put some more x's on here. Okay, choose some more and see what happens. So for instance, I can go all the way to, well, an easy number to put in this would be -4. So I'm going to choose to go and do another one. So -4 divided by -4 is +1. So I can find -1, 2, 3, 4, +1. Connect that. I'm kind of starting to see a curve going on here. It's not in the same direction, but I'm seeing something. Then I'm going to try 4 is going to give me -1. So 2, 4, -1. We can see a curve. You can go as far out as you need to go until you start figuring out what's going on here. But I could also add on 8, -8, oops, and +8. and I would get 1/2, and I would get -1/2. So 8, so this is 4, so it'd be 8. Well, it looks like I'm getting closer and closer to the x-axis in this direction. So I'm going to just go ahead and draw my arrow saying that it's going that way. And then 8 here, there's 4, there's 8 goes to 1/2. And that looks like it's going to go that way. So now what's going to happen here? Well, I know that this is undefined. So I know that it's not going to cross over this. Right here, I have this what's called an asymptote. Right? What that means is it's going to get closer and closer to that without passing over it. Okay, so you could go ahead and try 0.5 and see what you get. If I put in 0.5, I would, if I put in -0.5, I would get a +8. So -0.5 would send me all the way up to +8. 1, 2, 3, 4, 5, 6, 7, 8. Or you could also just remember what this looks like. So it's going to be a combination of making the table and also just kind of knowing what these graphs look like. All right, there we go. So you don't need, like I said before, you don't need to draw in your asymptote. I just wanted you guys to see it. But here's where it intersects. And so let's make sure we answer the question. How many times do they intersect and what are the points of intersection? So intersect two times at -1, 4 and 1, -4. All right, so we've graphed it. Now let's look at some modeling situations with this. So some real world problems. A gas station sells 2 bundles of firewood. How much would you pay for 10 bundles? Well, I encourage you to pause the video here and see what you can answer on these. You'll get a lot more of these videos if you're kind of challenging yourself and making them more interactive. So pause the video, see if you can come up with the answers, and then rejoin me when you're ready. All right, so how much would you pay for 10 bundles? Well, you could think of this a couple ways. You could first find out what one bundle is, or you go, okay, well, 2 into 10 goes 5 times. So I have 5 groups of 2, so 5 times 9 is 45. Then on this next one, it says, how much do you pay for one bundle? Each costs the same, so that means I'm going to take my 9 and divide it by 2, and I get $4.50. Write a rule relating the number of B bundles to the total cost C. When they're asking you for a rule, what they're saying is write an equation. Okay, so the number of B bundles to the total cost C. So if you didn't come up with something because you weren't sure what a rule is, pause and see if you can come up with an equation that's going to have B, C, and an equal sign in there. And then to give you a little hint, it's going to be either a direct variation, so an equation that looks like this one right here, or it's going to be an inverse variation. So that should maybe help you write your equation. All over the place here. All right. So the rule then, if you've come up with it, see if you have the right one. So B bundles to total cost. So it's going to be the cost equals C. The constant is 450 because for each bundle it's 450, and then I'm going to multiply it by the number of bundles I need. So is this a direct or inverse variation? Well, this equation looks like a direct variation. All right, same deal here. Pause the video, see if you can answer these questions, and then rejoin me when you're ready. Okay, the lottery is $1 million. There are 2 winners. How much will each winner get to take home? Well, I'm going to take this 1 million, divide it by 2, and each winner is going to get to take home 500,000. How much would each winner get to take home if there are 5 winners? Well, I'm going to divide this time by 5, and I get 200,000. So now we're going to write a rule. So we're going to write equation relating the number of winners to the amount of prize they get to take home. So the first time I had that there was 2 winners, so I divided by 2. The second time there were 5 winners, so I divided by 5. So if I don't know how many winners I have, I'm going to take the total amount and divide by W. And this will equal the prize they get to take home. Is this a direct or inverse variation? Well, if you can notice, I have 2 variables and a constant, and the constant is being divided by this variable here. So this is an inverse variation. Okay, so I left a couple problems for you to try. This is just graphing. So graph the following equations. Use your knowledge of these equations along with a table to sketch the graph, right? So you have to think about, what is this going to look like if I plot this out? What should this look like when I plot this out? Okay, and just keep in mind, we just did a few like this on the last couple pages here. So just look back through your notes and see what they should look like. And if you're not ending up with that, kind of mess with it and come up with different points until you feel like you've got the right look. But you're going to come up with some x's. That'll tell you what the y's are, and then you're going to plot them. Come up with some x's, plug them in, find out what the y's are, and plot it.